All right, so we want to find the inverse of this function. First thing I'm going to do, well, the same thing as y is equal to the square root of r squared minus x squared. All right, so x is, excuse me, we're going to swap out x and y. So this becomes r squared minus y squared. So I'm going to square both sides, so I get x squared is equal to r squared minus y squared. So then I get negative y squared is equal to x squared minus r squared. And then divide through by negative 1. I get y squared is equal to r squared minus x squared. Hey, this kind of looks familiar. So y is going to be equal to plus or minus, but probably just take the square root in this case, r squared minus x squared. All right. So this is our inverse function. But we're not done yet. I got to test this out. So f of negative 1 of x, we're going to get square root of r squared minus square root of r squared minus x squared all under the radical. So this becomes r squared minus, and then the square gets rid of the radical, so we get minus r squared, and then distribute the minus sign, it becomes plus x squared. R squareds cancel out, we were left over with x squared, and then we get x out. So that proves that. Then f of negative 1, well, it's kind of pointless for me to prove it, because if you look, the inverse and the regular function are exactly the same. If I do the inverse, I'm just going to be repeating what I just did. So it's this is a valid solution. So the inverse of the square root of r squared minus x squared is this right here. That's it.